Hi, students, and welcome to today's lesson. I'm Mrs. Levine. Today, we will investigate the question, how does motion in space compare with motion on Earth? Are you ready? Grab your pencil and your science journal, and let's get started. Have you ever looked up at the sky and noticed the moon? Sometimes the moon is big, bright, and full. Sometimes it's just a thin sliver. Have you ever wondered what visiting the moon would be like? Imagine walking on the moon. How does it feel? Do you think walking on the moon feels the same as walking on Earth? Well, if you're curious about visiting the moon, listen closely to this recording.
Altitude, velocity, right. 10.5 down, 220 feet. 15 forward. 11 forward, coming down nicely, 200 feet. 4.5 down, 5.5 down. 160 feet, 6.5 down, 5.5 down. 9 forward. Good. 120 feet. 100 feet, 3.5 down, 9 forward. 5%. 185. 875 feet. That's looking good, down a half. 6 forward. 60 seconds. Lights on. 6. Down 2.5. Forward. Forward. 40 feet down 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward, drifting to the right a little. 30, down a half. 30 seconds forward. 8. Contact light. Okay, engine stop. Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
Wow, listening to that recording is exciting. What do you hear in the recording? What do you think is happening? I hear people talking over a radio that has some static. Someone calls out numbers. Can you believe that this recording is of the first humans to ever land on the moon? The recording is amazing to hear. What do you know about astronauts landing on the moon? I know the first moon landing happened in 1969. That's a little more than 50 years ago. The newspapers in this photograph were printed on July 21st, 1969, the day after the first moon landing. Wow, what do you wonder about the first moon landing? I wonder who went to the moon. Maybe you wonder, what did it feel like to land on the moon? Or what did they do when they got there? We can read excerpts from a book to help us answer these questions. This book is titled Moonshot, The Flight of Apollo 11, written by Brian Flocka. This book is about 3 astronauts, Neil Armstrong, Buzz Aldrin, and Michael Collins. As I read, listen closely for information about the movement of the spacecraft, the astronauts, or objects in the spacecraft. Think about what you notice and what you wonder. After this lesson, you'll record what you notice and wonder about the way objects and people move in space in the Notice and Wonder chart in your science journal. You'll record your observations in the I Notice column. Your observations should be statements. For example, I noticed a spacecraft on the cover of the book. You'll record any questions you have in the I Wonder column. For example, where is the spacecraft going? This photograph is of the Saturn V, the spacecraft that launched the astronauts into space. At the very top are 2 other spacecrafts, the Columbia, where the astronauts sat on their trip, and the Eagle, which landed on the moon. Let's pretend we are in the spacecraft with the astronauts getting ready to lift off on our way to the moon. Are you ready? Okay, let's read. 10, 9, 8, 7. Ignition sequence started. Flames push hard against the pad, every second pushing harder. 6, 5, 4. But still, the rocket does not rise. Mighty arms hold it steady. Hold it till the countdowns finish. 3, 2, 1, 0. Liftoff. The rocket is released. It rises foot by foot. It rises pound by pound. It climbs the summer sky. It rides a flapping, cracking flame. It shakes the air and shakes the earth and makes a mighty roar. Armstrong, Collins, Aldrin ride the fire and thunder pressed in their seats, their bodies as heavy as clay. The rocket below them sheds parts as it soars. Boats explode, engines ignite. First stage, second stage, escape tower gone. Wow! Can you see the part of the spacecraft that the astronauts are riding in? The rocket flies lighter, the rocket flies faster. In 12 minutes' time, it's 100 miles high. They go rushing into darkness, flying toward the moon, far away, cold and quiet, no air, no life, but glowing in the sky. Whoa, can you believe we are in space now? As we continue reading, I want you to think about how objects move in space. Here, there is no up or down. An astronaut can spin in air and turn a floor into a wall or a ceiling to a floor. On those ceilings, walls, and floors, there are straps and screens and gauges, buttons, handles, hoses, and switches. I wonder why the astronauts are upside down or sideways. There are food and clothes packed into corners in flight plans, flashlights, pens, and cameras. And they float too. That's why there's Velcro everywhere for holding things so they stay put. Wow, so everything floats in space. I wonder why that is. Here, where everything floats, it takes some skill to eat a meal. That ham salad sandwich? Watch the crumbs. Soup? It comes in a bag dry as dust. Here, where everything floats, it takes some skill to go to sleep. There are no beds or pillows, no night or day. There is always, though, the hum of circuits, the whir of machines, the thought of where you are, and the thought of where you're going. And one more thing. Here, where everything floats, everything, it takes some skill to use the toilet. It takes pipes and hoses and bags. Wow, I wonder what it would feel like to float in space. If everything floats in space, I wonder, do objects move around or do they float in one place? But still ahead, there is the moon, cold and quiet, no air, no life, but glowing in the sky, glowing and growing. It takes them in, it pulls them close. Armstrong and Aldrin leave an Eagle and take it low and lower. They have just enough time and just enough fuel. They have a plan and a place to land, a chosen safe site among the craters. Remember, the spacecraft is made up of two different ships, Columbia and Eagle. Do you see them now? The Columbia stays above the moon, and the Eagle lands on the moon. It's amazing that these ships can travel together, then break apart and become two separate ships. Armstrong fires the rockets. Eagle slows and lower, goes until a spray of dust, a bloom of moon, flowers up around her. Slow and slower, low and lower, low and lower, landing. Armstrong calling from the moon. Armstrong and Aldrin walk its rough, wide places. They step, they hop, as light as boys. They lope, they leap. But in that black and starless sky, high above there is the earth, rushing oceans, racing clouds, swaying fields and forests. Eagle's landing stage becomes a launch pad, and 3, 2, 1, Armstrong and Aldrin fly the top of the Eagle up, up, up from the moon, their second liftoff of the trip. High above the moon, Columbia is waiting. Columbia and Eagle, two small ships, and Eagle, smaller than she was before, they dance, they spin closer and closer until Collins can dock and lock them together. Two small ships flown as one again. They leave the last of the Eagle behind them and fly together from the moon, which rolls beneath, which rolls behind, letting them loose, letting them go. High above the earth again, they skim the top of the sky. They slip from emptiness into air. They are flying, more like falling, diving down to the world below, flying, falling, fast, 400 miles every minute, falling fast, but now pushing on air and using the air and the shape of their ship to slow down, pushing on air, cutting down speed, building up pressure, and building up heat. Hot and then hotter until flame, until fire, now protected by shields, pressed again in their seats. The astronauts ride as a glow grows around them. They cross the sky like a torch trailing a blazing tail. Then drogue chutes, pilot chutes, main chutes open. The parachutes catch the air. The parachutes catch the sky. They slow Columbia's fall. Now slower, now safely, now swinging, now drifting, low and lower, in the last small piece of Apollo 11. Armstrong, Collins, and Aldrin return. back to family, back to friends, to warmth, to light, to trees and blue water. Back from the moon, they land with a splash. Wow, walking on the moon must have been very exciting. I have a lot of questions. Do you? In our next lesson, we'll find out what space is like as we visit astronauts on the International Space Station. I can't wait. Let's review your task for today. Complete the notice and wonder chart.
Today's lesson, I'm Miss Lee. Today we will continue to investigate the question, how does motion in space compare to motion on Earth? Are you ready? Grab your pencil and your science journal and let's get started. Imagine you are an astronaut traveling through space. What is it like? Now imagine living in space. Some astronauts do live in space on board the International Space Station. The International Space Station is a large spacecraft and humans have been living on it since the year 2000. Most astronauts visit the International Space Station for about 6 months at a time and someone is always there. Imagine you are an astronaut on board the International Space Station. What do you think you would see? Do you see all that blue color in the photograph? Do you know what it is? It is Earth. Can you guess what those white things are on Earth? Yes, clouds. From the International Space Station, I think you would even be able to see the continents. I wonder what the continents would look like from so high up. The area in the center of the International Space Station is where people live. The space is about the size of a 5-bedroom house, and up to 6 astronauts can live there at a time. But the International Space Station is not just a home for astronauts, it is also a science laboratory where they conduct research and learn more about living in space. How do you think the daily routine of an astronaut living on the International Space Station compares with the daily routine of a person living on Earth? How do you think they sleep? When they are working, do they sit, stand, or float? Astronauts do many of the same things that we do every day, but the way they go about their daily activities must be very different. After all, objects float in space, and so do people. Your task for today will be to answer the question, how is motion on Earth different from motion on board the International Space Station? How can we learn more about what life is like in space? I know. Let's look at a video clip that shows what one daily activity, eating, is like for astronauts. Whoa, do you see that? The astronaut's food is floating. That bag is just floating in the air and part of the taco almost floated away. Wow. What else did you notice in the video? Did you see that one astronaut is able to use his fork? Some parts of eating in space seem to be similar to eating on Earth, but the astronauts have to hold on tight to their food. Think about the activities you do every day, like sitting, brushing your teeth, or even playing sports. I think all these activities would be very different if we had to do them in space, don't you? Why do you think these activities are so different in space? Well, since everything floats, objects don't fall. Objects move differently in space than they do on Earth. Let's watch another video clip. In this clip, 3 astronauts are trying to play soccer in space. Wow, this game looks like a lot of fun. The ball is going all over the place, but the astronauts are still able to kick the ball. I hope they don't break anything. Tell me, what surprises you in the video clip? I am surprised to see that the astronauts cannot control the motion of the ball. Motion is the act or process of moving. When we watch the soccer ball move, we observe its motion. Let's watch the video one more time, but this time I want you to really pay attention to the motion of the soccer ball. Are you ready? What do you notice about the motion of the soccer ball? I noticed that the soccer ball doesn't fall, it just floats in the air until someone kicks it. And the astronauts don't have to kick the ball very hard to get it to move a lot. Wow. What do you wonder about the motion of the soccer ball? I want to know, why doesn't the ball fall like it would on Earth? Why is the ball floating and not rolling on the ground like it would on Earth? What do you think is causing the ball to float? Have you ever seen an object in your life that moves in an unexpected way? What objects have you seen that move in ways that are difficult to explain? I've noticed that some balloons float, but when I blow up a balloon using my breath, the balloon falls to the ground. Why do you think that happens? Have you ever ridden on an airplane? I wonder how airplanes can move through the sky without falling. And what about riding a bicycle? Why does the bicycle go in a straight line when the wheels move in a circle? Maybe we can learn more about the motion of objects by studying the motion of a soccer ball in space. How can we learn more about the motion of a soccer ball in space? What if we observe the motion of a soccer ball on Earth? We can compare the way a soccer ball on Earth moves to the way a soccer ball moves in space. In the next lesson, we will observe a soccer ball and notice all the ways that it can move. I can't wait. Let's review your task for today. Your task is to answer the question about motion on Earth and on board the International Space Station.